Hello and welcome to Module 2, the Hardened SPI bus interface. My name is Dave Baldwin and I am a field application engineer for the Lattice semiconductor. I will be describing a reference design and a demo design for the SPI bus interface on the MachXO2 programmable logic family, and Chris will be taking you through the demo. This module on the SPI bus slave interface will consist of two parts, a reference design and a demo design. The first section of this module is the SPI bus slave interface reference design. It will allow the user a quick implementation of the hardened SPI bus with ready-to-use code. A possible application fit with this reference design is using it with the MachXO2 as an I/O expander for pin-limited microcontrollers. The reference design also includes well-documented test bench with a SPI master, a memory module, a back-end interface, and the device under test or SPI slave. This slide gives a quick overview of the customizable parameters of the CAN solution so that the user can implement it to a variety of application needs. Shown here is a summary of those parameters and are found and defined in Table 2 of the application note. Some of those parameters are port numbers, data width, number of GPIO, and burst length. The command set that is supported is also shown here, but further described in the reference design documentation. The demo design of the SPI bus interface, described in UG56, takes a more in-depth approach to the SPI slave interface and allows the designer to control both sides of the SPI interface via the FPGA. It will require two Lattice semiconductor Pico evaluation boards, a Windows-based PC, some short wire connections between the two boards. A USB cable is provided in the Pico evaluation kit to connect the PC to the board. The demo included with this user's guide is a clock control example between two boards. We will next go into the details of the setup. This slide gives the user a general overview of the setup, and again, it is fully described in the user's guide documentation. The demo not only shows an example of the SPI interface, it includes simple application for a touch button input through CapSense pads and output through control of the board's LCD screen. Chris will now be taking you through this demo.
Thanks, Dave, and now we'll go over Usage Guide 56, the MachXO2 Master Slave SPI demo. So once you've downloaded your zip file from the website, you're going to see the following folders. There's going to be a bitstream folder, which contains the JEDEC files for both your MachXO2 devices, document folder, which contains all the relevant documentation. There's the Diamond projects. There's a master version and a SPI version. There's the simulation folder, which includes your do file or your macro file for your simulation tool. There's the source files for your Diamond project, and there's the test bench for your simulation. First, let's start off by programming the MachXO2 slave board. For that, I'm going to use Diamond Programmer. So we'll load up the Diamond Programmer tools. We're going to come in here. We're going to go under the bitstream folder, and we're going to select the slave version. Okay. Next, we're going to power up our board, and we're going to click Program. All right, so we've successfully programmed our slave board. You can see the clock is beginning to go on there. All right, let's program up our master. So we can go ahead and set the clock. Coming back to Diamond Programmer, select the master, and click Program. All right, so now we have both the master and slave program. Let's plug in both the boards. All right, so what we can see here, the clock right now is displaying all zeros because we haven't programmed it yet. So let's go over to the master board. Push 1. Once we push 1, the colon in the center is going to stop blinking to indicate we're in set mode. Push 2, we can change the hours. Push 3, and we can change the minutes. Once we're done, push 1. You notice that the slave board has now been configured with the time. Come back to the master, push button 4, and we can see the seconds that are being displayed on the clock. Push button 4 again, and you can see the clock running again. That's it for Usage Guide 56, and I'll hand it back to you, Dave.
Thank you, Chris, and this will conclude Module 2. And thank you, audience, for your time. And could you please take the time to fill out the online evaluation form shown on this slide?